Okay, in this video we're going to look at the idea of instantaneous acceleration off of a velocity time graph. So if we look at this velocity time graph, you see we have a positive velocity that increases for a while, then stops increasing and begins to decrease, so slowing down as I go back from zero, so it's not constant. If I wanted to find the average acceleration between any 2 points in time, let's say between time 1 and time 2 here, right, I would connect the 2 points and I would find the slope, the delta V over delta T. Which is my acceleration, my average acceleration. Okay. Now, as I bring these two time events closer together, so let's say time 3 and time 4. So connect these with a solid line. Oop. Again, I would find the slope of the line that connects them to find my average acceleration. But if I were to look at a single point in time, let's say t naught, and I want to know what's the acceleration at that point in time, what I'm going to do is, just like we did with finding velocity from a position versus time graph, I'm going to find the tangent line, or the line that essentially, if you were to zoom in on the graph at this point in time, real close, what would be the line look like? It would look like a straight line in this direction. So this is my tangent line. And the slope of that tangent line, whatever my rise and my run is, my delta V over delta T, would give me the instantaneous acceleration A at that specific point in time, in this case t naught. So A at time t naught, that's not a good at, is delta V over delta T of the tangent line. At t naught, which is my rise over my run. So, want to know instantaneous acceleration from a VT graph, find that point in time in which you want to know it, draw the tangent line, find the slope. Alright, let's look at an example. So here we have another velocity time graph with a number of different points identified. I want you to find the following. So go ahead and draw this down and then answer the following questions. When is the acceleration 0? At which moments is the object slowing down with a negative acceleration, slowing down with a positive acceleration, speeding up with a negative acceleration, or speeding up with a positive acceleration? So go ahead and pause the video and answer these 5 questions. Okay, let's go through these one at a time. When is the acceleration 0? Well, I have an acceleration of 0 where the slope of my tangent line is 0. So if I look at point A, I have a flat tangent line, horizontal tangent line. Point C, point G, and point I. So C, G, I, and A are all positions on the graph where the slope of the VT graph tangent line is 0. Therefore, the acceleration is 0. Remember, slope of VT is A. Alright, how about slowing down with a negative acceleration? So I have to be in the process of heading back towards the 0 line, and my slope has to be negative. So if I look at point D and find the tangent line here, at point D, I'm making my way back towards 0. So the velocity is decreasing. I'm slowing down. But because the slope is negative, this is a negative slope, therefore my acceleration is negative. So D, slowing down with a positive acceleration. Now I have to look at going back, moving towards the 0 line for my VT graph. Anything moving towards the 0 line, either down or up, means slowing down, moving towards a velocity of 0. Slowing down with a positive acceleration would be h. So in this case, the slope of my line right here is positive, but it's moving towards the 0 line, therefore it's slowing down. And finally, speeding up with a negative acceleration. So here I have to be moving away from the velocity of equals 0 axis, but in a way that my slope is negative. So we have f here. I'm moving away from v equals 0 with a negative slope, and then the other one moving away from v equals 0 with a positive slope is my spot B. So a difficult graph to interpret. Hopefully that helps you. A couple more questions. At what moments is the object 6 at rest with 0 acceleration, 7 at rest with a positive acceleration, 8 at rest with a negative acceleration? A little bit trickier maybe. So go ahead and pause and see if you can answer those. Okay, first thing is to be at rest, I must be at v equals 0. So my potential at rest spots are A, E, and I. So A and I have slopes of their tangent lines of 0. Therefore, their acceleration is 0, and they're at rest because they're located at a spot v equals 0 at the 0 line. Now E, if I look at the tangent line at E, it's a decreasing slope, so it's got a negative acceleration. So E is at rest, but with a negative acceleration. Now there is no spot where I'm crossing the line with a positive slope. Therefore, there are no examples of having a positive acceleration and being at rest for this graph.